name of this function? Yep, so it's cubic, and you could also write x cubed. So that's on the back of that card. So does everyone have that card? Write cubic and write x cubed. I'm just going to pause. And it is named the quadratic, and x squared is its function. So the next one I will do is another identify the parent function. And what is the name of this one? This one is just linear, right? It's linear, and instead of writing y equals x, let's write y equals mx plus b. So the line, linear, y equals mx plus b. All right. Half of a parabola. Does anyone remember the name of this one from last time? Yep. So this is the square root function, and it has that radical over the x, square root. So this will, you can practice the names. I think it also has you do this on the homework tonight. All right, so that one is square root. So then there's two different ones that are exponential. So those are the next two that I'm going to put up here. So this is one of the exponential functions. Would this be called exponential increasing or decreasing? So as you read it from left to right, it's getting smaller and smaller and smaller. So this is exponential decreasing. I'm not going to write, I'm not going to be testing you, I guess I should say, on like what the function would be, but an example might be 1/2 raised to the x power. That would be exponential decreasing. X is in the exponent, and it's a fraction less than 1. We're going to do a whole unit on exponential. So just knowing the name of the function and being able to identify it. So the other one is called exponential increasing. So the one that's going up to the right is exponential increasing. Exponential increasing. And something like 2 to the x power. So you're putting it on the back of that card. So that, I think, was pretty much the parent function ones, right? The rest are all about the transformation rules. Those were the parent functions. All right, so I don't know, in any particular order here, domain, equation. Let's start with this one. Okay, so can you find this one? That is a transformation that has gone to the left. So can everyone find the transformation that has gone to the left? Now this to me would be the back of your note card, and on the front of the note card, which we're going to put on the other side, is we're going to write the function, and then your brain has to tell you, ooh, did that go up, down, left, or right? So the equation of this would be, so on the back side, this is the absolute value of x plus 3. So because it's inside the function, and you can even put y equals if you want, but inside the function is opposite what you think, so it shifts it left 3. So as I'm going through doing these note cards, I would put this one face up, and I'd have to identify, okay, left 3. Then I would flip it over and see if I was right. Like, oh yeah, that's left 3. That makes sense? So that's that one. So that was to the left. Find the next one that goes to the right. So this graph of the absolute value. So that is the equation of y equals, and inside the function would be x minus 2, because it's being shifted to the right by 2. That way you can practice, okay, which one goes left and which one goes right. Inside, it's always opposite what you would think. So then there's an up and a down somewhere. So let's see. Can I put that one aside? Okay, so why don't you find the up? So here's the up. And the up, this goes on the outside of the function. So it'd be like y equals the absolute value of x up 1. So the plus 1 goes outside the function. And it's not opposite anymore. Plus actually means going up. So minus is what would mean going down. So for the down, sorry, it would be y equals the absolute value of x minus 2. Shifts that guy down 2. All right, the next one I want you to find is this one. So it's actually being flipped upside down over the x-axis. And that would be y equals the negative absolute value of x. So this is a flip over the x-axis. I did not include the flip over the y-axis, but that would be inside the function, like a negative x right there. At least if you have one of the two flips, you're like, okay, down is upside down. Write the range, write the equation. Let's do this one, because this is a stretch. Do you see the one that's steeper? So that's being stretched how tall? It looks like its new slope is up 3. So to do a stretch, that would be 3 in front of the absolute value. So it's 3 times as steep. I don't think I want these. I don't really want those. This one's good. Okay, and then find the one that's less steep. Can I move to the next one? Let me know if you are behind. So this one right here is the other transformation when it's less steep. So y equals 1/2 the absolute value of x. And I'm thinking the other ones are not, I want to write maybe the domain one. I don't think I like that double shift. Okay, let's do the domain card, because I would like you to know the domain for an absolute value function. What's the domain for any absolute value function? All real numbers, because these two arrows are pointing left and right, so those x values can go as far to the left and the right as they want. So the way you can write it the bold-faced capital R or just all real numbers. So x is any real number, the domain of absolute value. So I feel like the one that says write the equation for this function, that's not really memorizing a transformation rule, so I crumple that one up. But this is a good one. What's the range for this absolute value? So range, I'm starting all the way up here at 1, 2, 3, 4. Is that right? 1, 2, 3, 4. So my range would have to be y is greater than or equal to where you're starting at 4. So at least then you've got one domain and one range included in the note cards. Did you get them all kind of filled in? So you've got that as a study tool, and we'll do kind of a game with it tomorrow when we come in. I don't know, do you need a paper clip or, yeah, I gotta find some.